Hi everyone, welcome to my presentation. Today we're going to talk about the topic semantic classification with ELMO deep contextualized word vectors. Semantic classification is an NLP task. Natural language processing is a branch of computer science and more precisely, the branch of artificial intelligence or AI. Concerned with giving computers the ability to understand the text and the spoken words in much the same way human beings can. Motivation. Why do we need to study ELMO? So first of all, text tokens are not numerical, and we need to convert those words into numerical vectors so that computers can process them. Traditional word embeddings do the work, but are not able to capture contextual meaning of words. Other word embeddings are useful in only capturing semantic meanings of words, but fail to capture high-level information that might be even more useful. So let's consider the example here. The service was poor, but the food was. Here we have a key transition word but here, which indicating the second sentence should have the opposite polarity compared to the first half. So how do we let a computer do the work? The motivation for ELMO is that we're looking for a solution to incorporate both word-level characteristics as well as contextual semantics. What is ELMO? The red Muppet character from Sesame Street? No. Essentially, ELMO is a framework to convert a token into deep contextualized word embeddings. How does ELMO work? ELMO word vectors are computed on top of a two-layer bidirectional language model. And here's the bidirectional language model. So we can see here, ELMO is not a vector. It is a function to determine what the vector of the word should be according to its context. It is a combination of raw word vectors and intermediate word vectors from the first layer and the intermediate word vectors from the output of the second layer. And if we take a look at the mathematical form, we can see that ELMO itself is a function instead of a vector. An example of applying ELMO. So let's take a look at the two following sentences. I'd like to walk in the afternoon. Second, let's go for a walk. Here, walk in both sentences is the same word, but walk in the first sentence is a verb, and walk in the second sentence is a noun, so they have a slightly different meaning. Now let's extracting ELMO word vectors out of the same word walk. We can see that these two word embeddings have different vectors. Let's go to the real game. This time we'll train ELMO with a dataset containing 10,000 tweets. Each tweet is a unique customer review, and each review is either positive, labeled as 0, or negative, labeled as 1. And here's the function to extract ELMO vectors. And we do a classic train test split. Result. So we use the simple language model logistic regression, and we use the ELMO vectors as an input to the logistic regression, and we train the model to predict on the test dataset, and it's very impressive. We achieved the overall accuracy of 90%, considering we only used ELMO vectors. And here's the confusion matrix. So basically it's telling us how many correct predictions the model has done. Takeaway from ELMO. What is ELMO? Embeddings from language models is a natural language framework to represent words in deep contextualized word vectors. ELMO representations are a function of all the internal layers of bidirectional language models. How is it different from other word embeddings? ELMO capture both word-level characteristics as well as contextual semantics. ELMO, what applications can ELMO do? ELMO representations can be easily added to existing models and significantly improve the state-of-the-art performance across 6 challenging natural language problems, including question answering, textual entailment, and sentiment analysis. Thank you for watching my representation.